Hello everyone, this is Phil Reed, and I'm very pleased to be talking about Enscape best practices for lighting materials and graphics, focused on the use of Revit. I don't think anyone in this meeting has been using Revit longer than me, and as much as I love Revit, I can tell you there's some idiosyncrasies about the material editor and lighting, and they're very simple things. This is not hard. So in the next 20 to 30 minutes, you're going to have an enormously improved understanding of lighting and materials and graphics. My company is partnered with Enscape, and we support and sell Enscape around the world. If you have questions about Enscape, I will be very pleased for you to email me. My email address was on the previous screen if you need to know how to contact me. All our training and support is complimentary, and we love helping customers with Enscape. Now, the interesting thing about Enscape is that it is a real-time application, but I want to drop back a little bit and talk about workflow, because in order to get to a really useful place with lighting, materials, and graphics, you have to understand how Enscape is working. So let's talk about hardware a little bit, about best practices for workflow, and then get into the tips and tricks. Now, Enscape, if you're not familiar with the application, is a really unique real-time application in that it is real-time in real time. There's no exporting involved. You actually just start it. So think of Enscape as like a play function. You've got Revit open. You want to see a high-fidelity real-time rendering of your project. You push the play button. And as you make changes in Revit, the changes update real-time in Enscape. Now, there's a number of ways to get information out of Enscape. With one click, you can go into VR, and Enscape supports all the major headsets: Oculus Rift, HTC Vive, and Windows Mixed Reality. On my laptop, which is a consumer-level gaming laptop, I can create a rendering that's 2K resolution and very high fidelity in about 5 seconds. That's incredibly fast. That's 10 to 12 images a minute. Animation files can be created. In the previous release, it was actually only about 1 second of rendering per minute rendered on my laptop. In the last release, this increased by a factor of 6. I can now render 5 to 6 seconds of animation in 1 minute. Enscape also allows you to create Google Cardboard panorama files. These are mono or stereo images that not only can be rendered in Enscape, but they can be uploaded to the web. There's no charge for this. It's all part of the service. And when you upload that panorama file to the web, you can send the customer a URL or a QR code that they can scan with a mobile device and be prompted to look at that panorama file on a mobile device. It's really, really easy. Now, there's 2 ways of looking at a fully 3-dimensional explorable model with all the materials and all the lighting. You have the option of creating a desktop version, which is a standalone executable file that contains the Enscape application, plus all of the materials, plus all of the lighting. You can walk around freely, you can change the time of day. The visual fidelity is beautiful. Now, the caveat is that desktop executable requires hardware sufficient to run Enscape, because that exe file actually contains the Enscape application. And then you're, in that sense, you need hardware that has a discrete graphic card, and you need Windows. But the visual fidelity is the highest visual fidelity you get. A little less visual fidelity, but a lot of flexibility, is the new browser standalone file. That file does not require Windows. It simply requires Chrome or Firefox web browser, and you can take your model, upload it to the web, send a customer a URL, and if they have Chrome or Firefox on a Windows or Macintosh computer, they can open that web standalone and fully explore it. It's really, really easy. So those are the ways you can get information out of Enscape when you don't want to see it live. Excuse me. Now for hardware, this is my recommendation. The minimum that Enscape suggests to run Enscape is 2 gigs of RAM on a discrete graphic card. And personally, I think that 2 gigs of RAM is great for viewing an exe file. It's not great for viewing your design application and Enscape side by side, because the frame rate and the throughput is going to be a little bit slower. So when you make a change in Revit, it's going to take a moment for it to update in Enscape. My recommendation is to use consumer level gaming cards with at least 8 gigs of RAM. That's going to give you really great throughput. It's going to give you the flexibility and ability to use VR headsets. At a base level, I think that the best graphic card, best base level is the NVIDIA 1070 GTX. That's a graphic card that probably cost about $400. It's got 8 gigs of RAM. Those graphic cards, they have a form factor for the desktop and they have a form factor for the laptop. My Windows laptop is very thin and very light, and it uses a 1070 GTX. Now, about headsets. As I mentioned before, Enscape supports Windows Mixed Reality, HTC Vive, the Oculus Rift. I think you can actually even view files that are the panorama files in the Oculus Go. I purchased all of these headsets, and the one that I really like is the HP Mixed Reality headset. This is my best recommendation. The HP Mixed Reality headset is really easy to set up. It doesn't have any external sensor towers. It actually has 2 cameras that are built into the headset. The build quality is fantastic. On the consumer version, you can just raise the visor. The visor actually is on a hinge with a little halo strap, and you can just raise that hinge up to look around. It's really, really easy to wear. It's very good build quality. It also has a very high pixel resolution, so there's 1440 pixels per eye, which is great. As far as cost, this is where the HP Mixed Reality headset shines. You can purchase the HP Mixed Reality headset for as little as $150 refurbished as new on Amazon. I've already purchased 2 of them. The meeting that you will have to discuss which headset to buy is going to be more expensive than just buying the HP Mixed Reality headset. I think you'll love it. It's a great, great headset. Now, as far as workflow, depending on the hardware that you have, or if you just want to know a couple of best practices for large project management. Number 1, if you've got monitors side by side, 4K monitors, and you've got Revit open on one screen, it's full screen, you've got Enscape on the other screen, full screen, and you're sitting back from your screen about 18 to 20 inches, you can't see 4K resolution. Even though the screen's producing it, you can't see it. So I would recommend that in order to increase frame rate and get nice, smooth performance, drop the resolution of that 4K monitor down to 2K. That's going to decrease the pixel count, it's going to increase your frame rate, and it's going to perform smoother. If you're running it at 4K and it looks great, that's fine. But if you're noticing any lag whatsoever, or you want to have the fastest graphic throughput from design changes that you make in Revit over into Enscape, drop your resolution of your second monitor that Enscape is docked onto. Drop it down to 2K resolution. You won't notice any difference in visual fidelity. The other thing that you can do is use your section box in Revit to actually limit what Enscape has to see, right? So let me give you an example of this. I've got this project in Revit open. This is the one we're going to use for lighting, materials, and graphics. But imagine this is a multi-story, enormously large project. And you're inside the building, and you can't even see everything inside the building because you're inside the building and you've got Enscape running over here. So you're happily using Enscape. If it's not necessary to see the entire universe of your Revit project and the entire universe of your Enscape project, you can limit what Enscape has to compute by using your section box. Now, there's 2 ways to do this in Revit, and the first way is really slow and annoying, and that's what most people do. They open their 3D view, their default 3D view, and they turn on their section box tool. And then they meticulously select the section box, and they select the grips, and they manually stretch and pull this so that it only shows what you want to see. That's a really slow way to use your section box. There's a much better way. I would recommend, of all the 3D views that you have in your project, use your default 3D view. That's the view that you get when you push the little house icon. Your default 3D view, by default, should be used to drive Enscape. And the reason is the quick ability to use your selection box tool. So let me show you an example. We're going to go to the plan view. All right, so we're not even working in 3D right now. And in Revit, you could select a room object, you could select a couple of pieces of geometry, and then use your selection box tool to isolate what Enscape has to compute. The selection box tool builds a section box in your default 3D view. That's why you want to use your default 3D view to drive Enscape. So you're working on an enormous multi-story project, but what you really care about is a room and a couple of adjacent spaces. You select them in any view, and then you use your selection box tool to isolate what you selected in your default 3D view. I would even recommend going an extra step and mapping a keyboard shortcut to that option. So you can select a couple of options, keyboard shortcut with your selection box. Now you've built a section box around your project in the default 3D view. If you're using your default 3D view to drive Enscape, that's all Enscape has to compute. So you can have an enormous million-square-foot-plus project open, make holistic changes inside of Revit, but if you're inside the building and you have limited visibility and you're trying to make the design decision impact what you see, there's really no point in having the entire project computed in Enscape. And this will dramatically increase the updates between your Revit file and your Enscape file. Okay, so let's go back to Revit, turn off the section box, and keep going. Now there's different pricing points for Enscape. You get a monthly license, you can get a fixed seat license, you can get a floating license. The floating license is your best option. It has enormous flexibility. You simply start Enscape and it checks out a license and you start working. Now, the floating license also has the flexibility of a built-in grace period. So if you need to go off-site and there's no internet access, there's no process of checking out a license and going out of the office. And it's much easier than that. What you want to do is while you're in the office, start Enscape. Count to 5, then close Enscape. That checks the license back in, gives everyone back in the office the ability to use all your Enscape floating licenses, but that initiates a 24-hour grace period for you. So you can go off-site, start Revit, start Enscape, and it's fully functional for 24 hours, okay? When you have questions, my company's right here in Charlotte, North Carolina. You can call me, you can email me. Our rule of thumb is if we're awake, we answer the question. So wherever you are, if you have an Enscape issue, please reach out. We're honored to be helping Enscape and supporting Enscape customers around the world. There we go. That's a little preamble. Now let's talk about lighting and materials and graphics. The tricky thing about lighting is more than lights. Lighting is about illumination, and there's lots of illuminated things that are not lights. So looking at this screen, from the upper right, we have a light switch that glows in a low light condition. Think about that in terms of appliances and equipment and other furniture and features in your architectural project that need to glow in a low light condition to appear natural. Or think about an exit sign. Exit signs do not schedule in Revit as lights. You don't want to nest light objects inside of them to get them to appear to glow in a low light condition when you're trying to visualize a life safety egress study. Or think about a reception desk. That kind of accent lighting would be very, very tedious to create by nesting Revit light objects, but you still need to create the appearance of illumination. And this is really easily done with a material editor. However, at the lower left, we have a light bulb. And this light bulb has very fine filaments that appear to glow in excess of the light. And this kind of effect can also be really, really easily created. The next feature that we have is materials. And you may not believe this, but I think in the next 10 minutes you will. Revit is capable of enormous visual fidelity when it comes to materials. But you have to apply the material in a particular way. And that has to do with choosing the right asset. So we'll cover this briefly. And then finally, there's graphics. Look at a real estate posting for a house, and you'll notice that in that building or in that residence, there's more than just walls and doors and windows. There's furnishing, there's lighting. As a matter of fact, the lights are often on. It's a thing that makes the building lived in and natural. But there's also printed material. There's graphics. And in your architectural projects, if you limit your visualization to only geometry, you'll leave a lot out. The view will actually, the real-time environment will actually seem cold. Now, the great thing about graphics is they're really just materials in Revit, and you can use materials to communicate an enormous amount of geometry detail, much like game engines, without committing to building a lot of detailed geometry. So think about an expensive piece of equipment or a detailed piece of equipment or a very expensive appliance. You can spend a lot of time building all of those reveals and all of those buttons and all of that detail and never get to a natural looking component when you view that in a real-time environment. However, you can keep the geometry really simple and apply an image. And the image can be marketing signage, it can be the image on a computer screen, it can be directional signage, it could be a menu board. That image could also be the appearance of an expensive piece of equipment. So instead of modeling all these buttons and dials, you simply apply an image from the manufacturer. Visually, you won't be able to tell the difference, but by doing so, you keep your Revit models nice and clean, very light, keep all the detail in the schedules. They'll still tag properly, but when it comes to viewing those objects in Enscape, the visual fidelity will be fantastic. So let's cover lighting, materials, and graphics. We're going to go back to Revit. And here's the scene that we can that we're going to use today. Pretty straightforward. It's not large, not because Enscape can't handle enormously large projects. It's not large because we just want to help you focus. And if I have a large building open, it's going to be distracting. So let's go back to Enscape, and I'm going to navigate around. And I'm going to change the time of day. And as we change the time of day, you'll notice that things start to illuminate. And this is what I mean by it's important for your scenes to appear natural, not just photorealistic. So what does this mean? That means exit signs need to glow in a low light condition. It means if you have accent lighting, tape lighting, neon lighting, colored lighting, you need that to glow in a low light condition. You need computer screens that glow in a low light condition. There's a really practical application with illumination in Revit in that you can't nest a Revit light family inside of a system family. So your stairs, your balusters, your railings, I'm noticing a lot of those conditions actually have very fine, subtle illumination now via LED lighting or via some strip lighting. And it's not possible in Revit to nest those system families with lights and have them behave predictably. So in this case, we're just building a bit of geometry, applying a material to it. If you have a light that needs a bit of help, so for example, we have this Edison type bulb here. I think this is a good metaphor for the condition where this is actually a light, but we're going to use self-illumination to just kick it up a bit, to make it appear more natural. Okay, so this light is a light. It will schedule as a light, it's illuminating as a light, and even the table that the light is placed upon illuminates from this light object. We're getting also a bit of light off of this cloth panel. Let's understand how this light works and how we can make it look even better. Okay, so I'm just going to open this light family, and we're going to look at it in 3D. And this yellow object, that yellow object is your light source, and the light source is part of a Revit light family type. So this light is going to render as a light, it's going to schedule as a light category. These light sources are fantastic. That's the light source definition. And in 99% of your regular Revit lights, things that need to schedule as lights, that light source definition is going to be fantastic. Now, you have different light shapes. So you have point sources, linear sources, rectilinear sources, and spherical sources. And you have the ability to control the distribution throw of those lights as well. So you can have a complete spherical distribution or just half of a distribution direction. You can have cone-shaped lighting. You can even have IES files nested in your Revit light families. But if you want to go the extra step for a light family like this, you can use self-illumination to augment this light family. And actually, the difference is noticeable and really important. So what's happening in this light family right now is we have this little wire, and it appears to illuminate. It appears to illuminate just like this neon lighting in the distance. But that light wire, that little bit of geometry is actually not illuminating. It's reflecting the light definition that's inside the family. If we want this light to illuminate, just like if we want a material to illuminate or if we want geometry to illuminate, that's a really, really easy thing to do. What we're going to do is assign a material parameter to that geometry, and that material appearance type is going to be a generic asset. That's really, really important. So let's go to the Appearance tab, And here's our generic asset. It's got a shaded color. And then with a generic asset, you simply check this box for self-illumination, give it a meaningful luminance value, and here's the difference. And this is why it's noticeable. At the moment, you're seeing the appearance of light on that geometry, but it's really just the reflection of the light inside that family. Once we give that little piece of geometry luminance, here's the difference. Now that little bit of wire appears to illuminate, and it appears much more natural. So when you have very subtle lighting conditions that are strangely geometrically shaped, such as tape lighting, accent lighting, neon lighting, even these little side tables. If you have a piece of furniture that has the appearance of luminance, some accent lighting for that piece of furniture, you simply select the geometry, apply a material parameter with a generic asset type, and now you can check that box for self-illumination and give that geometry the appearance of illumination. Really, really easy to do. Now let's talk about materials. Okay, Revit's almost 20 years old. And when Revit, think about 20 years ago, people weren't even used to designing buildings in 3D, much less rendering. So you needed a really easy to use way for people to render. And that easy to use way is called procedural materials. They're hardwired for certain kinds of behavior. So you have procedural materials for metal, masonry, stucco, tile. There's just an enormous amount of procedural materials. They're shortcuts to get to predictable behavior. They're easy to use. The flip side of ease of use is sometimes less control. And that's what we're seeing with this curtain wall mullion. So I just want to change the time of day. And do you notice how that mullion appears to shimmer and flicker as we change the time of day or as we move around? That kind of condition is indicative of a procedural material. Once you stop moving around, the material settles down, it renders, and it looks quite natural. But the challenge is that every time you move, or as you change the time of day, you're getting this unnatural appearance. The other thing that happens is if you're wearing a VR headset, you can never really stop moving, not unless you put the VR headset down on a table and walk away from it. When you're wearing that VR headset, it's constantly recalibrating its position. So you're going to get that weird specular reflective artifact for anything that's made of metal. And it looks really unnatural. It's going to distract your customer right away. You're going to give them a VR headset, they put it on, they're trying to focus on the overall design, and right away they're going to say, why are all the aluminum mullions kind of shimmering? Doesn't look very good. And then you've got to stop and explain it, and that's distracting. So let's just avoid that condition altogether. And here's how we're going to do it. We're going to open up the material editor. I'm using a keyboard shortcut here to do quickly. And we're going to scroll up to those aluminum mullions. And we're going to select the appearance tab. Now, this material doesn't say generic, it says metal. I would recommend using all generic assets. And I think for the most part, even Dan Stein would agree with me. Here's the reason why. Your procedural metal assets, there's only 8 kinds of metal. And there's only 4 levels of finish. You're probably never going to use polished, it looks too reflective, and you're never going to use brushed because it looks too dusty and desaturated. So now you're stuck with semi-polished and satin. And when you make changes or you select 1 or 2 of those, it makes a big change. It's just not enough control. The other thing is let's say you're starting to use a metal asset type, and then you say, I've got a beautiful seamless texture that I want to use for metal. How do you assign it to this asset? You can't. You can't use a material and assign it to this particular procedural asset. If you look at your Revit template for your company, which has probably evolved from the Revit template from Revit, you'll notice that it's full of procedural materials. And you'll notice that if you look at steel as a material, they're using a type that's stainless steel. So the first thing that you're going to see in your project is you open it up, you start to walk around an Enscape, you turn off the walls, and you're looking at the mechanical system, and all of your structure looks like it's been dipped in chrome and polished, and that is incredibly unnatural. So we're not going to use procedural assets, that's my recommendation, but you don't want to delete the asset and recreate it, because that asset name is associated very likely associated to dozens of object categories and objects. And if you delete the material name, you have to manually go back and reassign that relationship, and you'll never, it's tedious and you'll never get it right. You'll forget something. So here's what we want to do. The better way to do it is select this little button, and this replaces the asset type. So we can toggle open the appearance library, and you can see all of these asset types that are procedural. And the one we want to use is the generic asset. So simply select default, double click generic, and that converts your procedural asset into a generic asset. Now you have an enormous amount of control, and it's really, really easy. So what we want to do for something like an aluminum mullion, let's just give it a light gray finish. And for the glossiness, which is the finish value, let's turn that to 90 and just select OK. We'll go back to Enscape and we'll move around, and you'll notice that that specular kind of artifact is gone. And if we change the time of day, it's not doing that weird shimmering artifact. That's why you don't want to use procedural materials. It's very, very apparent if you use a procedural material for metal. It's also very obvious if you use it for a material like wood. So I'm just going to change the time of day so that the sun is reflecting off of this surface. And if you ever see a wood floor or wood surface that looks like this, that's this perfectly reflective, you know that you're looking at a probably a very cheap plastic faux wood material. So we don't want wood surfaces, even though this is photorealistic, it's got dust and noise and scratches. We don't want wood surfaces that look perfect. We want wood surfaces that have the appearance of grain. This is also indicative of a procedural material. So we're going to select the floor, go to the type properties, select the structure, and let's look at a material that's procedural material for wood and why you have limited control. We can certainly apply an image to this procedural material type, but we only have 4 levels of finish. So once again, you can't dial in that careful amount of finish that you want. The other thing is with your relief pattern, you only have a range of 0 to 10 to control that material's texture. Let's look at the same image type applied as a generic asset. Now we have much more control over that material. We have the ability to control the glossiness or the finish on a range of 0 to 100. We have the ability to control the texture, not on a range of 0 to 10, but on a range of 0 to 1,000. And that's really, really important. So simply by changing this material type from a procedural asset to a generic asset, we've introduced the ability to control that material in a much more bespoke way. So I'm just going to select OK. Before I do, let me go back to this wood floor and show you what this material looks like as a procedural wood asset, and then select it and apply it as a generic asset. Okay, and there you have it. That material is now reflecting the light. The light appears to dig down into the grain and reflect off of that surface in a much more natural way. And that's the subtle effect of using a generic asset over a wood procedural asset. So that's lighting and materials. Let's look at graphics. We're going to turn around and just lift our view up a little bit and change the time of day. Okay, graphics can be used for television screens, equipment, appliances, and they're really, really easy to apply. I don't like using the decal tool because decals are host dependent. If you delete the host, if you apply a decal to a wall, or a lot of decals to a wall, and then that wall is inadvertently deleted, all of those decals disappear, and you'll have to manually go back and replace each one, get it the right size, and then hope that nobody deletes the host again. So instead of using a decal, I would recommend just building the component family and applying the image. But the reason a lot of people don't do that is because they go, well, it's hard to control an image. It's hard to control the UV mapping on a component family. And in the next few moments, you're going to find out that that's no longer the case. There's actually a really, really easy and predictable way to do this. So let's open this component family in Revit. We'll just zoom in. This could be a painting. This could be a television screen. This could be directional signage. And we're going to select Edit Family and go to a realistic view. We don't have to select the geometry and apply the material to the entire piece of geometry. We only need that image to appear on a single surface. And the way we're going to apply the image is using the paint tool. But we want to apply the image with a paint tool in a very particular and useful way. Before you apply the image, you want to create a material and finish parameter. Maybe it's an instance parameter because you want all of those images to have the ability to be unique for each individual computer or menu board or signage in your project. Or maybe it's a type parameter because you want every desktop to have the same desktop image. Now, we've selected the image, we select the paint tool, and we have two options to apply the paint. We can apply the canvas image, or we can apply the parameter that refers to that image. We want to apply the parameter. We'll see why in a moment. So we select this option, we click on the surface, and right away, Revit's going to place the lower left corner as the origin somewhere in the center of that geometry. Now we have to probably change the size of the image, and we have to set the origin correctly. So I'm just going to go to the material properties, select the appearance tab, and let's look at the material properties for this image. Because the geometry is 4'11" by 3'3" in this instance, we want to set the sample size for the image as 4'11" by 3'3". You do have the option to tile or not tile the image, but you can just leave that option on because the material just bleeds off the top of the geometry once it gets to the edge. So that's fine, it's one less step. We don't want to use the position tool. This is the trick. Don't use a position tool to try to set the UV mapping for that image. What you want to do is the same thing that we do in the project environment for any material that repeats or that tiles. Revit automatically controls the origin of a model pattern with the origin of an image. That's an automatic thing. If you move that model pattern for masonry coursing and you render that scene, the image for the masonry is moved as well, or for a ceiling tile, or for flooring patterns. The image size for this model pattern, and it's a model pattern, not a drafting pattern, is 4'11" by 3'3". It's the same size as the image, and the image is the same size as the geometry. In the family editor, we can use a material, or we can use a model pattern, the same way you use a model pattern in the project. You have to do this in the family editor for a family component. You hover over the model pattern, you tab through, you press and drag the model pattern. That moves the image and it locks it. That sets the UV mapping in a very, very straightforward way. So let's go to a front elevation, zoom in a bit, and use the Align tool. And we're now aligning the model pattern. Since the model pattern is the same size as the geometry, it disappears in your hidden line view. And if we go to a realistic view, you can now see that the image is properly mapped. That's the first step, and that's really, really easy. Let's overwrite this instance, which changes here, and which changes here. The beauty of this technique is not only that it's easy to do the first time, but that you have the ability to swap out that image with another image in a very easy, fast, and predictable way. So here in our Enscape view, I'm going to save a 2K image. My keyboard shortcut is Shift-X. I've just saved a 2K image to the desktop. And in so many cases, your customer comes at the last minute before an important deadline and says, all these images, this marketing theme that we have to swap them out. How do we do that? Well, if you've used a material parameter and applied that image with a paint tool, simply by selecting the geometry, we're taken to the type or the instance parameter to quickly and easily swap out that image. So we go to the Appearance tab, we select the old image, we browse to the new image, in this case, mine's right on the desktop, and select Open. That's it. We've already established the size of the image, we've already established the origin, there's nothing else to do. So it's taken that 1920 by 1080 image and stretched it to 4'11" by 3'3". If you want the image to appear to illuminate, check this box. And the larger the image, the less illumination that you need. We simply have to browse to that second image again. So I'm just going to go back to the desktop, select the image. It's remembered the origin, it's remembered the size, and we select OK. Immediately that updates in Enscape. And if we change the lighting to a low light condition, you now see that that image appears to illuminate, which is what you want with a material in a low light condition that appears to glow. So that's it. That's lighting and materials and graphics. If you have any questions, please reach out. You have my email address from the beginning of this presentation. I'll just show you the email address again. The other thing is, if you'd like a studio trial for everyone in your company, if you've never used Enscape, or even if you have, if you want a special trial for your entire company, send me an email. I'll send you a special trial key. It'll work for everyone. If they have a computer that'll run Enscape, it'll work for everyone from the time of install. So you might install it today for yourself and then a week later for someone else, but everyone will get a chance to get a taste of Enscape and really understand how to use it well, and hopefully have just a wonderful user experience. That's it. Thank you all very much. If you have any questions, please reach out to me. Have a great day and chat to you soon.